In this video, I'm going to go over the questions that were in homework 3. I know some of you had some trouble with it, so I want to clarify that here. This is the first question, and in this first question, we're looking at what the inheritance pattern is of this particular pedigree. The options are basically dominant or recessive, and when I approach these types of questions, I always first evaluate it for if there's anything in there that tells me this is going to be a recessive pedigree. Those kind of jump out at you. In looking at this one, this particular area right here tells me that this is recessive. So I know that's the answer. Now, if I just explain why that is, when you have a recessive pedigree, it's possible to have two parents that don't have the trait, and then suddenly it shows up in the offspring. So notice here that Ava and Sean don't have this particular trait, and their child, Cammie, does have it. So that means it's going to be recessive. Once I know that it's recessive, that means any of the dark-colored individuals, we can assign them a genotype of little a. So I could go through and do that. And then it also tells us by default that any of the individuals that have a white color to them, they're going to have at least one capital A. They might have a second one there. Okay, so that's question 1. Now, if we move on to look at question 2, it's still looking at this particular pedigree, and it's asking us which one of the individuals with the dominant phenotype are going to be homozygous dominant. So we're really looking for any individuals that are capital A, and the dominant phenotype, remember, is the white individuals. So just going through here, again, any of the black ones are going to be little a. So we can label that. And then just going through this, if we start at the top, Arnold, we know because he has a white color to him, he has at least one capital A. Well, notice that he has two children, Troy and Freda, who have little a. That means they must have inherited that little a from both parents. So that tells us Arnold is heterozygous. His children, Sarah, she would have definitely gotten a little a from Arlene, her mom, so she's also going to be heterozygous. And the same thing for Ava over here. Now, at the same time, if we look at Ava and Sean, notice that Ava and Sean both had a child that is little a, so that means that they both must have been carriers. Okay, and then just continuing to work our way through. If we look over here at Sally, we don't know anything else about Sally other than the fact that she's not displaying the trait. Okay, noticing also that she doesn't have any children that have this disorder. It is possible that she could be capital A. Their children, Drew and Sam, we know that for sure they're going to get a little a from dad, Troy. So both of them are going to be heterozygous. Okay, and then if we look at Tracy, we don't know any other information about her other than the fact that she has at least one capital A and she doesn't have a child with the disorder. So it is possible she's also capital A. The child, Cade, could also be two capital A's. So our answers here are going to be Sally, also Tracy, and Cade. Those are the ones that have the possibility of being capital A, or homozygous dominant. Now, in the next question, we're kind of looking at the flip side of that. We're asking which one of the individuals with the dominant phenotype are heterozygous. So here we're looking for individuals that have this combination. Again, if they're dominant looking, they're going to be white. And it's basically all the ones we didn't select in the previous slide or previous question. So we knew that Sally was capital A, or had that possibility. Tracy also did, and Cade also did. All the other white-colored individuals here could be heterozygous. So that would include Arnold. I'm going to circle him. We could also have Sarah, Ava, Sean, Drew, Sam, and that should be all of them. Okay, so those are all the individuals that we know are going to be heterozygous. Okay, in question 4, we want to figure out what the genotype of Arlene is. Okay, remember that the dark color in this pedigree is recessive, so she has the recessive phenotype. The only way that she would have the recessive phenotype is if she's a little a. Okay, so that would be the answer for her. In question 5, we have a new pedigree that we're looking at, and we're asked about the mode of inheritance. Again, look at it and see if there's anything there that tells you that this is definitely recessive. We have actually the same situation here that we had in the last one, where we have two parents that don't have the disorder, and then they have a child that suddenly does. And anytime we have that happen, it is going to be a recessive pedigree. So we know it's recessive. And then we just need to know, why is it recessive? Okay, it is recessive because you have a couple that is normal and they have affected children. Okay, this would never happen if it was a dominant pedigree. In this next question, we're looking at the same pedigree, and we want to know the genotype and the phenotype of Allison. If we look at Allison over here, she has the dominant phenotype, and because she has the dominant phenotype, we know that she has normal eyes, because this is a pedigree for dry eyes, which means the colored-in individuals have dry eyes. So she has normal eyes. We know that she has at least one capital A. And then if we look further at her children, she has two children, Miles and also Mia over here, that are little a, little a. They would only be two little a's if they got a little a from both parents. So she must be heterozygous with normal eyes. In question 7, we're asking about Miles. Miles was her child. We actually looked at him a little bit in the previous question. He's little a because he does have the colored-in phenotype. And so he has dry eyes because this is a pedigree for dry eyes. In question 8, we want to know about Carly and Jim. Okay, so if we look at Carly and Jim on here, we want to figure out the probability that their next child will be affected with dry eyes. To do this, we have to first come up with the genotypes of Carly and Jim. Well, Carly is colored in, so she's little a. Jim, we know, has at least one capital A, but if we consider that he has a child that is little a, that means that he must also be heterozygous. So drawing the Punnett square for these two, this would be my Punnett square. We can see that half of them down here would actually have dry eyes. So that would be our answer to this question, that we would expect that half of their children would actually have the dry eyes. Moving on to this pedigree, looking at the inheritance pattern, if we observe whether we have a situation where we have two parents that don't have the disorder and then a child that does, I don't see that anywhere. In fact, every time a child has it, at least one of their parents has it. So that right there is a good indication that this is going to be a dominant pedigree. For example, notice that Annie down here at the bottom has at least one parent, Edward, that has it, and Edward has at least one parent, Carl, that has it. Okay, so this is going to be dominant. So we know it's this, and it is dominant because we have a couple of normal and affected children can have both normal and affected children. That is true. Okay, we cannot have normal parents, so two parents that don't have it actually have a child that does have it. Okay, so it is going to be dominant here. Looking at this, now we want to evaluate Joe and Julie and the probability that they will have a child that is affected. Well, since it is a dominant pedigree, that means any of the white individuals are little a. Okay, so Julie is actually little a. And then looking at Joe, Joe has at least one capital A, okay, but he also has multiple children that are little a. So keeping that in mind, each of these children would have had to get a little a from both parents. So Joe is going to be heterozygous. So if we want to know the probability of certain phenotypes and genotypes in their children, we draw this Punnett square. And looking at this, the probability that their child will be affected, we're looking for the dominant phenotype, and it is going to be 2 out of 4, which would reduce down to 1/2. Question 11, we're looking at Edward, and we want to know the most likely genotype of Edward. Well, Edward looks dominant because he's colored in, so he's got one capital letter there, so one capital A. And then notice that he does have children that are little a. Okay, so based on that, they would have inherited a little a from both parents. He would have to be heterozygous, so that would be Edward's genotype. In question 12, we're looking at the genotype of Amy. Since this is a dominant pedigree, any of the white circles are going to be recessive, so she has 2 lowercase a's. This one, another pedigree First, we have to look at what the inheritance pattern is and decide whether it's dominant or recessive. Once we know that, we can answer the question. Looking at this part of the tree, we can see that we have two parents that don't have it, suddenly a child that does. So it is definitely going to be a recessive pedigree. That means that anyone that is black in color is little a, and if they're not, they're going to have at least one capital A. So Jill, which we're asking about here, has at least one capital A, but she does have a child that has it, which means she must be heterozygous or she must be a carrier. So her and Jack would be heterozygous. If we want to know the genotype of Charlie, since we decided that this is a recessive pedigree, he is recessive looking, he's going to have two lowercase a's. Question 15, we're looking at Sean and Terry. Okay, so Sean and Terry down here, we know that Sean is little a. Terry, we know has at least one capital A. We don't necessarily know 100% for sure what the second allele is going to be for Terry, but we don't have any history of children being affected by this disorder. We don't know anything about Terry's family, so we make the assumption that she's going to be homozygous dominant. So if she is capital A, and Sean is two lowercase, then we know that all of their children are going to be heterozygous. So we would expect that there's no chance that their children are going to end up affected in this case. Question 16, we're asking about Angie and Doug. If we look over here, Angie and Doug, they both are dominant looking. So we'd say they both have at least one capital A, but they have multiple children that are little a. Okay, so based on this, they must both be heterozygous or they both must be carriers. And then if we draw the Punnett square for them so that we can predict their offspring and what their genotypes might be, here we have the Punnett square, and we can see that 1 out of their 4 children we would expect to be affected here. So the answer is going to be 1/4 is the probability the next child will be affected. Question 17, we're asking about which of the individuals would not be carriers. So which ones must not be carriers? Well, just looking through here, Jack and Jill have a child that is affected. So we know they're definitely carriers. Okay, Ruby and Max have affected children, so they're both carriers. We know that, Charlie and Lola, they don't have children that are affected, but all of their children would have inherited a little a from Charlie. So these are all affected, or possibly carriers, is the way we would say it. Angie and Doug have children that are affected, so they are both carriers. Okay, so just looking at this, we could also say that Sean would definitely have passed a little a to all of his children, so they would be carriers for sure. And if we look at what we have left, the ones that we don't necessarily know that they're carriers, we could say, Jack we've crossed off, Ruby we've crossed off, Mandy's been crossed off, Doug has been crossed off, Ty crossed off, Marie crossed off, so the only one left in this list is going to be Walter. Walter, we don't know. He could very well be a capital A because both of his parents were heterozygous, and we could have got that 2 dominant A combination passed on to him. Okay, and then in this last question here, looking at the pattern of inheritance, we know that this is recessive because, again, we've got 2 parents that don't have this particular disorder, and they have a child that does. So Charlie has it, so it is going to be a recessive pedigree.